Hello everyone. In this video, we will be discussing electron beam machining process parameters, advantages, disadvantages, and applications of EBM process. So already in the previous videos, very clearly we discussed like what is electron beam machining and how it is carried out and the need for electron beam machining. So all those things we discussed, and even we have seen the similarities between electron beam machining and the laser beam machining, except the mechanism we follow to get the source, the way of the removing the metal removal, it is almost similar to the laser beam machining. So first we'll start this video with the electron beam machining process parameters. As we know that process parameters which directly affects the machining characteristics in electron beam machining. So what are they? The very first in process parameter is nothing but the accelerating voltage. So here the electrons get accelerated at a very high voltage. So what is the voltage level? Here we need to remember is 50 to 150 kilovolts. So that is the voltage rate, and the beam current related to the number of electrons emitted by the cathode are available in the beam. So the beam current can be as low as 200 microamps to 1 amp, and the pulse duration, if you see, means the pulse duration can be of as low as 50 microseconds to as long as 15 uh, um, uh, microsecond, like a meter seconds, and energy per pulse. So power per pulse and lens current. So all these are the other process parameters. Then moving to the spot size, where the spot size is controlled by a degree of focusing achieved by the electromagnetic lenses. For a lower spot size, the metal removal would be faster, so the size of your hole would be smaller. And the power density, if you see, means the energy density, and the power density is governed by energy per pulse duration and spot size. And what are the design considerations? Means we will see. So the non-reflective workpiece surfaces are preferable. This is very important. Already in the laser beam machining process also we have studied. Here we will be going with the non-reflective workpieces, because the electron, the ionized, like what is that? That fast moving stream of electron beam can able to reflect. In case if you are going with a highly reflective material, so the selection of material should be very important. So that is why non-reflective workpiece surfaces are usually preferable. And sharp corners are difficult to produce, and deep cuts produce sharp cuts. I think, hope you remember the same thing we have discussed even in the laser beam machining. And we need to consider the effects of high temperature on the workpiece material. Okay, and the part should match the size of the vacuum chamber, and we need to consider the manufacturing the part as a number of smaller components. Okay, then we'll move to the next one, advantages. So all these advantages we should discuss in detail. So here the first advantage is extremely close tolerances can be maintained. See, first of all, we are preferring these kind of electron beam machining for like very smaller size and even very complicated designs and shapes we are preferring. That too, in that the extremely close tolerances also can be maintained, means we can able to see the accuracy and the way of machining is carried out, and the heat affected zone are minimum. Since all these operation, if you take starting from the cathode, the tungsten filament, and even the magnetic lens, the diaphragm, all those things, if you say, that also kept in the like a vacuum chamber, and even the workpiece where the process is happening, even that place also, it is completely covered with the vacuum chamber, and even we have separately vacuum pump to remove the excess iron thing, and a proper cooling system is also provided. So obviously there is no chances of heat affection in the workpiece material or for the any other major components. And moving to the third advantage, it can machine almost any material irrespective of their mechanical properties, except the material which is highly reflective, like I can say glass, certain ceramics like marbles, and polished materials like copper, silver, aluminium. So such kind of materials are little reflective, but it doesn't mean that we cannot completely do the machining process. We can do it, but avoiding such kind of material means we can save our time and even the complications in the viewing can be avoided. Apart from that, any material can be machined by using this particular process. For this non-reflective material, like even laser also is not recommended. For that, we can go with like electrical discharge machining. We can go, or like any other ultrasonic machining. Such kind of a process is recommended, and the beam can be concentrated in a very small area, and so overall the space requirement for this electron beam machining process is not much. So the space area is also very less, and it produces a better surface finish and narrow curve. So which is very important, and it was the major drawback in the laser beam machining. So that drawback also we can overcome by using this electron beam machining, and the thermal distortion is least. So it is a proof that there is no distortion of the thermal energy, and the process is fast because it is entirely non-mechanical, and it is having its own demerits, and that without discussing also a few of them we can list it out. The very first would be the equipment cost. As usual, like other non-traditional machining process, here also the equipment cost is very more, and even the operation cost is also more, and the interaction of the electron beam with the workpiece surface produces hazardous X-rays. So hence shielding is highly recommended. So whenever this electron beam is what is that hitting the workpieces, so the surfaces it produces X-rays. So we should be very careful, and this is the side effect we can call it as. But if you are providing a proper shielding, we can manage the effects which the X-rays are producing. But anyway, it is an because proper monitoring and proper prevention care should be taken, and the vacuum is essentially required, because without vacuum the electron beam, the concept we cannot think out. So vacuum chambering and proper maintaining, it is a drawback, and because of very low material removal rate, the process economically only for small volume, but like wherever only small portions the excess material is removed, only for such cases required. For the bulk metal removal, usually it is not recommended, and skilled labor is required to accelerate the electrons, because the person should be highly skilled, like at what temperature and what should be the electron flow rate, and all those things can be decided only with the skilled labors, and very high voltage is required, as we discussed. 50 to 150 kilovolts is required. So generally a lot of electrical energy is required, so that is an additional expensive, and the process can machine only thinner parts. So the thicker size and all those things is also not recommended. Then moving to the applications of electron beam machining. So electron beam machining is particularly suitable for producing very small diameter holes, so down to 0.002 inches, and it is specially adopted for micro matching. Major applications of electron beam machining include matching in thin materials, cutting of slots, and drilling of holes with very high depth to diameter ratios, usually more than 100:1, and machining of wire drawing dies having a small cross-sectional area. And electron beam machining is also used as an alternative to light optics manufacturing methods in the semiconductor industry. Because electrons having a shorter wavelength than light and can be easily focused, so electron beam methods are particularly useful for high resolution lithography and for manufacture of complex integrated circuits. Welding can also be done with an electron beam, notably in the manufacture of aircraft engine parts. Particularly, they are very specific with the welding applications of electron beam machining. So with this, the last part of module 5 gets completed. So advantages, disadvantages, applications, and process parameters with all the technical information we have discussed. So with this, module 5 is getting over. Thank you.